Hey everyone, my name is Ronak back with another video, and in this video you are going to learn Hashmaps. So this is the fourth video in the data structure and algorithm playlist for interview preparation using Python. So let us get started. So if you certainly go for any data structure course, any data structure, first it is always covered are arrays. Then you come across stack, then queue, then linked list, then trees, then graph. So if you look at procedure, this is good from the point of view of examination, but this is not, I would say, certainly recommended with the point of view of interview prep. In interview prep, you have to first cover arrays. Then I would recommend hash maps. Then after hash map, I would recommend stack. Then I would recommend linked list. Then trees. Then queue. And in the end, graphs. So essentially, prioritization is the key, first thing. Second aspect to look at it is the likelihood of the questions that you can get. Okay, so likelihood of the questions you can face. And in my personal learnings and basically whatever I have learned till now for many years, I can assure you that you will find a lot of Hashmap implementations or Hashmap questions as compared to stack. Okay, so there is high possibility of getting a Hashmap question when you compare it with linked list, trees or graphs. See, trees and graphs are asked at many big tech companies. But if you focus on medium tier companies, array, string and Hashmap are the essentials. Okay, we talk about the essentials. Those are essentially arrays, strings and Hashmaps. Even when I have solved some advanced concepts such as sliding window, I have used Hashmaps. So Hashmap is used almost every single where. Now let us start by looking at its structure. So Hashmap, which is data structure, which works with key and element values. So it looks something like this. So here you will have keys, key 1, key 2, key 3 and so on. And here you will have element 1, element 2 and so on. So all of these keys are unique and they are mapped to every single element in the form of hash. So I am not going to go into a lot of theory of it, but essentially it looks something like key is mapped to every single element. Elements can be repeated, keys cannot. Keys are supposed to be always unique and of same. So that is the way you tackle the Hashmap problems. And we will directly start with some of its implementation, then we will look at some problems. So my suggestion is that you should learn Hashmaps before anything. Once you are done with arrays to a certain extent, please go and learn Hashmaps. Otherwise, do not keep it pending, in my personal opinion, because Hashmap is being used almost till the end of all the questions. Whatever questions I have personally faced, even when I was solving some two-pointer or sliding window, I have used Hashmaps. So many questions have Hashmaps in them. So like I said, there should be key and element. Now in Python, this can be implemented using dictionary. So now let us look at its implementation. So I'll say py. Okay, so over here I'm going to now type the code. So Hashmap starts by declaring like either two curly brace Okay, so you can most likely call it. Okay, so an empty hash map has been created. You can also say hash map is equal to dict like this. So this gives you your hash map. Now let us start by adding some values. So let's say hash map. The way you add the value is you take the key. Okay, so the key is going to come over here. So now let us say lorem and let us keep it equal to 5. And now if I check hash map, I get lorem is equal to 5. Okay, so lorem is the key, 5 is the element. And elements can be repeated, keys cannot be. So I'll say hash map. Now I'll make new key ipsum and let's say 5. And now if I check it, it says lorem first key, first value 5, second value ipsum, value 5. So elements can be repeated. Now you can perform many operations on it also. Okay, so one of the way is that I can check for hashmap dot pop. I can pop the element from it. So elements are pop using the keys. Okay, so if I say ipsum and then I check hashmap, it only keeps lorem. Okay, now let us again relationalize it. So in an empty manner. Okay, so now it is an empty hashmap. Now in this you can perform let's say comprehension. So we can say hashmap is equal to, inside this I'll say key and then I can give you the value. Okay, so we can check for let's say I raised to 2 essentially. Okay, I raised to 2 for I in the range of let's say first 6 elements. And now I can check hashmap and I get all the squares. So this can be also performed on it. And now if I check hashmap dot values, I get the elements, all the elements in the list format. I can also check hashmap dot keys. So keys basically give you all the keys. Okay, so key and element can be retrieved using these two. You can also run a for loop to get the values. So for, we can say value in hashmap dot values. I want to perform something, so I'll just print all the values. Okay, so I get all the values, which are essentially the squares. You can also print the keys. So for key in hashmap dot keys, I'll just print the keys. So let's say key, I get all the keys. And similarly you can go for key and value, both of them. So for key and value in hashmap dot items, so this works as an enumerator. And let's say print key as well as value. Okay, so I get all the keys as well as value. So this is the way the basics of the hashmap work. Now let us start by some problems. So let us start with the first problem, which is basically contains duplicate. Okay, so let us start with first problem. Problem 1, contains duplicate. So you will be given an array, let's say 1, 2, 3 and 1, something like this. So if there are duplicate elements, so you have duplicate element, return true. Now the most casual way you can solve this is using two loops. But practically that solution, or you can also use 2 pointers. Okay, so you can start right from here, and if they don't match, you are going to move the right pointer. But I'll show you the hashmap solution. The way you can solve this is that you can either look in the hashmap. So we are going to use these values along with their count. Okay, these values along with their count. And we will basically run a for loop through the array, and if that value, current value is in the hash map, we are going to increase the count by 1. Okay, So whatever value we have, we are going to increase the count of it in the hash map by 1. Else we are going to add it, hash map. Okay, so h of m value, and we will say is equal to 1. So essentially this array 1, 2, 3 and 1 will be stored in the hash map like 1 of 2, 2 of 1 and 3 of 1. Okay, we'll actually even solve this after we write the code. Okay, so let us now focus on the pseudocode. Apart from the value, then you are going to check for the keys. Keys are essentially what you have in the left. Okay, so I will check for the hashmap keys, and I will check that if in keys, so I will run a for loop for keys to certain extent. If any value for a particular key is essentially greater than 1, I'm going to return true. We will take an example, don't worry. If hashmap key is greater than 1, return true, which indicates duplicate. Else base condition is return false. Now let us actually take an example to make this more understandable. So 1, 2, 3 and 1. So start by declaring a empty hash map. So you will run through the array. So I starts from here. Now is the value in hash map? No. In such a scenario, you are going to work with this. So hash map value. So whatever value I am getting over here, which is essentially the value, you are going to take that value and you are going to assign the element of that key as 1. This is the first step. Then the process repeats. Okay, the pointer of the for loop comes over here. Is 2 available? No. So I am going to say 1 is equal to 1, 2 is equal to 1. Again the process repeats since the pointer is over here. So is 3 available in the existing hash map? No. So 1 colon 1, 2 colon 1, and I add 3 colon 1. Then the pointer comes over here. Okay, now is this value available in the hash map? Yes. In such a scenario, I'm going to update the count of the element by 1. So 1 colon 2, 2 colon 1, 3 colon 1. And now I'm going to run this. In this, I'm going to check for the keys. So essentially your keys are 1, 2 and 3. Okay, for the elements 2, 1 and 1. So I'm going to store these keys in the key. And I'm going to run a for loop over that key. So let us say for k in keys. And I'm going to check if any key of that hash map, any key is greater than 1. Okay, is greater than 1, like these values. If they're greater than 1, it contains a duplicate. Okay, so since your hash map, I'll draw it over here. 2 colon 1, 3 colon 1. Okay, so if hash k is greater than 1, the pointer is for this key. Yes, it is greater than, it is 2. So we certainly return true because it is duplicate. Because you were adding the duplicates, you were increasing the count using this, that if there existed a value in my hash map, I'm going to increase the count. So whenever that count is like greater than 1, I'm going to return true. Else, if all the counts are 1 till the end, we are going to return false. So this is the way this algorithm works. Now let us actually code this. So in the hash maps, I'll make contains duplicate .py and let us copy it from the Leetcode. Okay, so this is basically list and it returns a boolean. So now let us start by declaring a hash map. So we will say dict, okay, an empty hash map. So now for I in the range of essentially the length of your nums, which is the input array. If the nums of I, which is your value, okay, is in hash map, is available in the hash map, I am going to say hash map with the value nums of the I plus and equal to 1. Else hash map nums of I, okay, nums of I, which is your value, is equal to 1. So the element will be 1. Now I am going to say keys is equal to hashmap dot keys, which will give me all the keys that are available in my hash map. Now again I run a for loop for k in the keys. If any hash map key is greater than 1, I return true, or base condition is return false. So we are done with the code. Now let us write an entry point for it. So SOL object for the solution, and let us take the example from here itself, okay, which is nums is equal to 1231, 1231, and now we are going to print the boolean. So SOL, which is the object dot contains duplicate, and I pass the nums. Now let us try to run this. So in the hash maps, I'll say Python contains duplicate. It says true. Okay, so now let us copy this code and paste it here. Now let us run this. Okay, all the test cases are successful. Now click on submit. Okay, the solution gets accepted. Now let us look at the second problem. The valid anagram. So this is your problem 2. So you will be given 2 strings. So let's say string 1, string 2. So an anagram is something that if the words are jumbled, they match. Okay, so something like anagram is equal to something known as angram. So you have each word for everyone. So A is there, N is there, M is there, M is there, A is there, D is there, R and A. So there is, in this string 2, there should be all the words that are available in the string 1, even if they are jumbled. So this is a very difficult problem to solve using 2 pointers. So now we are going to use hashmap for it. So how would you actually solve this? You will use the string 1 values, put all of them into the hashmap, okay, in the value pairs along with the count. So key and element will be there. So you are going to add all the characters with their counts. You are going to add all the characters with their counts. Then from the string 2, you are going to use that hashmap for the reference, and you are going to delete all the counts for the characters. You are going to start deleting them, and in the end you are going to check if any of the keys, are essentially not equal to 0. So let us write some pseudocode for it and run an example. So you declare one hash map. After declaring the hash map, run a for loop on the string 1. String 1, you run a for loop, which essentially adds the elements. So it first checks. So if the string element is in hash map, okay, is in your hash map, you are going to increase the count like we did for the earlier example. So hash map, so string of, let's say, I will be increasing its count by 1. Else you add the element, okay, add the element as 1 to the key, and then you are again going to run a for loop. So for loop on string 2, and again you are going to exactly do this same procedure, but you are only going to decrement the count. Now if there are exactly the same number of anagrams, all of your keys should be exhausted to 0 as of now. So that is the reason you put the keys in your hash map in the form of array, and if any of them has the element not equal to, so basically not equal to 0, you are going to return false, that it is not an anagram. Else base condition is return true. Now let us take an example for this. Let us take rat as string 1 and string 2 as cat. Okay, so these are not the valid diagrams because R and C are different. So first you start by making one hash map, empty hash map essentially. In that, first you are going to go with the R and you are going to check, is R in the hash map? No. So you are going to say R colon 1, then A colon 1, then T colon 1. Okay, so this first for loop process is done. Now the second for loop, you are going to now use this string. So you go over here and you check, is C available in the hash map? No. In such a case, you are not going to decrement anything. You are going to just, let's say, return false. So you can break it right from the here. But now let us take an example that like ART, something like this. Okay, so this is a valid anagram. It checks for A, yes. So decrement it to 0. Checks for R, decrement to 0. Checks for T, decrement to 0. Now all of the values are 0. Then this final condition works. It will check for the keys, and if any element is not equal to 0, it is going to return false, else return true, that it is a valid anagram as a base condition. Now let us write some code for this. So I'll make a new file over here, valid anagram .py, and let me copy the Leetcode. Okay, and now let us start it. So hashmap, I'll make a dictionary as a declaration. So for I in the range of the length of the string 1, which is S, if the character of the string is in the hash map, so I'll say hash map for the string of I increase the count, else I'm going to add that particular character with respect to 1. Now again write a for loop for j in, let's say, range of the length of t, which is your second string. Okay, so even if there are 2 for loops, some people might say, okay, it is not time compliant. What I would suggest you that it is time compliant. The reason is the for loops are not nested. So if they are performing themselves one after the another, it is essentially adding. So it is again going to be order of n. Okay, the time complexity is going to be order of n, because let us assume that there are 3 for loops. So it is essentially 3n, which is again order of n. Okay, if the loops were nested, then it was order of n square time complexity. Anyway, so for t of j in the hash map, if it is in the hash map, I am going to decrement the count. Okay, so essentially it is going to be t of j minus 1. Else I'll just say, or I can just say return false. I can break it from here, because if it is not available, it is not a valid anagram. In the end, I'll take the keys. I'll say hashmap.keys. Okay, I'll check for all the keys, and I'll say for k in the keys, if that hash map of the k significantly is not equal to, if any of the key is not equal to 0, I'm going to return false, or the base condition is return true. And we are done with the code. So now let us write some entry point for it, and I'll make an object. So let's say SOL for solution, and let us take their example itself. Okay, so which is anagram and nagram. Okay, so I have two strings. Now I'll print the boolean of it. So SOL for the solution is anagram, requires two strings. So SNT. And now let us print this. So let's say valid anagram. It says true. So now let us take this code and copy it in our Leetcode. Click on run, performs on all test cases. Now click on submit. Okay, so solution has been accepted. Now let us work with our third problem, which is something that we had left earlier, and I had even promised you that I'm going to cover it. It is going to be two sum. So problem 3. Let me use a different pen. Okay, so problem 3. Two sum. Okay, so essentially you are given an array, let's say 2, 7, 11 and 13, and you are given a target. So you have to return two elements that exactly their addition is going to be the target. And we had solved this in the arrays using two for loops. So since these for loops were nested, the time complexity was order of n square. So now you can use Hashmap to make it linear, which is order of n. So this is more time efficient. So such a solution you can do using Hashmaps. So now let us head to the two sum. What you have to do the beginning is start by declaring one hashmap. Okay, declare hashmap, an empty hashmap essentially. Second step is take the keys and the values. So do a for loop for it. So key as well as value for basically the array that you have. So you cannot unpack it using the dot items just like Hashmap. So you will have to enumerate. So enumerate the key and the value. So essentially the index and the element, okay, of the input array. And then find a difference between the target and the current value. I'll tell you, we will take an example so it will make the intuition clear. And now if that difference is in the hash map, okay, it is in the hash map, in such a case just return the hash map current difference, that will give you the element index, and let's say the key, current key that you are going to use. Else on the base condition you have to say hash map of the value is going to store the index, and in the end you are going to return. So this is the way you are going to solve it. Now seems confusing, so for that we will take an example. So let us take an example. Let us say 10, 13, 9 and 15, and the target that you want to find is, let's say, 19. So essentially the 10 and 9, if you add them you will get 19. So we will now solve this using linear complexity. So first, after you enumerate, you will have the key and the values. So in the 0th index you will have 10, on the first index you will have 13, on the second index you will have 9, on the third index you will have 15 as per array. So first we start with the 0. It is targeted on the 0, which is giving you 10. You find the difference. So difference is going to be target minus the current value. So it is going to give you 9. Now this 9, is it available in my empty hash map? No. Add it into hash map. But how you are going to add it into hash map? See, if difference is in the hash map, you return this condition, else you work with this. So you essentially store the current value, which is 10, with the index. So 10 with the 0. Okay. Now in the for loop, it moves to the next step. This is over. So here you are going to check again. 19 minus 13, you will get 6. Okay, so difference has been calculated. Now if this 6 is available in the hash map, no, it is not available in the hash map. In such a scenario, you are going to add it. So you say you will add the value, okay, not the difference. So 13:1, which is the index of it. Then this gets executed, you move to the 2. Now you will again check 19 minus 9, which is going to give you 10. Now you will check if the difference is in the hash map. Yes, this current difference calculated is available in the hash map as one of the values. In such a scenario, you are going to return the hash map difference, which is the key. So it returns the value of it, which is 0, and the current key that you are at, the current key, which is 2, and you get the answer. So this is the way you get the answer. So 0,2 has been achieved, and if you check 0 and 2 added give you 19, which is your target. So this is the way you solve it. Now let us write some code for that. So let us move on to the toSum. So I'll make a new file, which is toSum.py, and paste this over here. So it expects a list and gives back a list. So start by making an empty hash map. So I'll say dict. After that, I'll run a for loop. So for key as well as elements. So actually we are doing in this format. Otherwise we can say for index and the value. Okay, index and the value that you have for your particular array. So in enumerate for the nums, we first calculate the difference, which is essentially target minus the current value that you are holding. Always work with a whiteboard example, okay? So if the difference is currently available in my hash map, I'll just break out of it by saying hash map with the element of the difference, which is difference is your key, and current index. If it is not available, in such a case I'm going to add it. So hash map with the value is equal to the index, and in the end I return an empty array if nothing is found. Okay, so this is a linear solution. So now I'll say main, and I'll make an object for the solution, and let us take our example. So which was 10, after that 13, 9 and 15, and let us give the target as 19. So it should return as 0 and 2. So let us now take the outcome, which is a list, and we'll say sol.toSum. It takes nums as well as target, and I'll print that outcome. And now let us try to run this. So py toSum, it gives us 0 and 2. So it is working. So let us copy this solution, paste it over here, run it. Submit it. Okay, so this is a more time efficient solution. So this was it about the hash map. So now from the next tutorial onwards, we will be taking things up a notch. So we will be working with a lot of another algorithms. You will obviously see hash maps many times. Okay, and always I would give you a suggestion that if you are working with some kind of problem and you do not understand the code, do the whiteboard solution that I'm doing. Take a pen and paper and do it. Go line by line, take an example, go line by line. That is the best way to understand the intuition. The only difference between let's say a decent programmer and a great programmer is that the great programmer has the strong intuition of looking at a problem. So go line by line and perform whatever it is written in the code. That is the best way to do the detailed analysis of how the particular algorithm is giving you the output. Okay, even if the solution is very hard, try drawing it. And this pen and paper technique itself was the only that has actually helped me, because earlier even I thought that was not much essential, but later on I started writing, like thinking about the solution, how I'm going to approach it, draw it on the paper and then try to code it. So that is a great way to think about a problem. It will give you a better analysis and an intuition of how to write I would say efficient code, because To sum had order of n square time complexity, and we actually brought it down to order of n. So this is it for this tutorial, and I hope you might have learned something or the other. And if you like my content, please do subscribe to my YouTube channel. And the link to all of the material for the today's tutorial will be in the description box below. So you can click in the link and be headed towards the GitHub repository that has all of the whiteboard concept of today as well as all the problem solutions. So I don't know what I might be covering in the next tutorial, but most likely I'm thinking of some advanced algorithms which encompass a lot of medium level problems. So till then, thank you for watching. Goodbye.